Diagram 1 shows two parallel forces. Right? These are the parallel forces. The forces give rise to a couple M. Diagram 2, line of action of the forces are move and the distance L/4 to the left. Right, so basically the distance hasn't changed. The force hasn't changed. So the answer should be still the same. So you want to work it out. Solution, diagram 1. Right, torque M equals to F times a quarter L and times 2 because both of them are the same. This one times perpendicular distance. That force times perpendicular distance. So you can add them up. So it's half FL. Diagram 2, the same thing. Half L, that's the distance between the forces. The torque is your, in this case, is your anti-clockwise moment. No? Force times half L, so it's the same. Okay. Are you with me now?
Oh, yeah.
Answer is the same. Because it hasn't changed the distance. The perpendicular distance is still the same.
What do you mean by that? Oh, yeah, because...
You just shift it a quarter
okay.
L/4, that's all. So it becomes half L. 30 is still half L. Both of them still half L. Hasn't changed. Right? We say torque is force and perpendicular distance. That's all. So it's still the same answer. Can. Which part is not clear?
Okay, can.
Any more question to ask?
21 also.
21. This is your ruler. And the length is 0.3 meter. It's pivoted. There's a pivot at the center. Opposite forces, these are the couple. 2 Newton and 2 Newton at 50 degrees. Is applied to the end of the ruler, creating a couple as shown in the diagram. What is the magnitude of the torque of the couple on the ruler?
I got D.
It should be take 1/4 and perpendicular distance. That's the perpendicular. This is 0.3. That's your D. Perpendicular distance is your 50. The torque is force and perpendicular distance. Perpendicular distance, the force is 2 Newton, take 1 force. And perpendicular distance is your 0.3. Far away from the angle is 0.3 sine 50. The answer is donkey. Can? Your question only involve up to D only, no E. Any more question to ask?
Next one also. Like 2 more.
A heavy uniform beam of length L supported by 2 cords. As shown in the diagram, what's the ratio of T1 or T2 of the tension in the cord? Right, they are very kind for you. When they told you heavy beam means it has weight. So the weight must be at the center of gravity. Center of gravity is uniform, means it the center of gravity halfway. The length is L, so center of gravity is half L. So draw the diagram, taking moment about G. No point in taking moment about the tension there or the wire there because you need the two tension. We take moment about G because we don't want W. Now clockwise moment equals some anti-clockwise moment. T1 times 2/3 L. Sorry, T1 times half L is center of gravity to the length. The whole length is 2/3 plus 1/3 is 1, is L. And T2, right, this is half L, this 1/3 L, so you still got L over 6, half L, right, 2/3 L minus half L, still got 1/6. Take the ratio, right, take the 2 over to the other side. This 2 divided by 6 is 1/3. Can. Yep, which one you don't understand or need me to explain further?
Um,
Yep. Which one you're not clear?
yeah, clear.
Anymore? The rest you can try out in your free
Okay.
time. Let's start a new topic. Okay? Are you happy with that?
Yeah. Um,
Okay,
okay, last question, 23, can ah?
23, okay? Same. This one is measuring, that's your 1 meter rod, non-uniform. Yeah, so yeah, non-uniform. So the center of gravity is not at the geometrical center. It's not at the center there. The rod is laid on the support. Right? That's the support. There's a support there. Across two top balance, as shown in diagram. The balance previously set at 0, give a reading. So basically measure mass. From there can calculate the weight. Where is the center of gravity? So they want to find center of gravity. Right? G is the geometrical center, center of gravity which is uniform rod lah, or midpoint lah. C is the center of gravity. It is usually towards the side with the heavier mass lah. Right? That's your C. And let CG be X, because that's what we want to find. And G is 9.81 times 8.1. So that is where the weight will act. There's a distance X. The geometrical center to the end is 0.5 meter. Moment about C. Take moment about C because we don't know the weight given. Now you can calculate it, but it's easier if we take C lah, because the two of them we know already from the mass given at the support there. Right? So we use sum of clockwise equals sum of anti-clockwise. So the distance from the center of gravity to the end is 0.5 meter. So the support there will give a reaction P, which is 0.36 times G. G is 9.81. So we take moment about C. We have our that P times that distance there, perpendicular distance there, 0.36. This is 0.5 minus X, is 0.5X. And we have another reaction force Q, right? It's 0.24 times G. That's the weight lah. So the reaction force will be the same as the weight. So it's the distance there, right? That's the force times X plus 0.5. So we can simplify it and then calculate our X. 0.1 meter to the left. Then,
Okay.
so okay, we will start a new topic. Happy with that? The rest you can try out yourself. It may be more challenging than the rest. Okay, we will start at 4.3 density and pressure. So basically, this one summarized for you like page 114 in your note. Right? What we are going to learn, we're going to define density. We're going to define pressure in the fluid. We want to calculate this one, derive this equation. You can use this triangle to help you if you want to find density. That's the mass, density, volume. You want to find mass, you just cover the mass. So it's density times volume. You want to find density, it's mass divided by volume. You want to find volume, you cover volume, it's mass divided by density. That's what they use in IGCSE lah. At A level, we just want to find mass, you just take the volume across, rho times V. Then upthrust is given in a formula sheet. So we won't bother about reference. You can use your own textbook. Okay, that's your syllabus. Oops, sorry, too fast. Right? Know what is given in the formula sheet and data. Acceleration of free fall is given. Hydrostatic pressure is given. Upthrust is given, the formula. Right? Know what is given. Okay, density. What is density? Physics, we go to define our terms. Density is a physical property of matter. As each element and compound has its unique density associated with it. That's how we know. Right? If we find density, we can roughly guess what's the element or the compound. Density is defined in qualitative manner as a measure of the relative heaviness of the object with constant volume. So we compare density by comparing both of them the same volume. And this gives us the heaviness of the object. For example, a rock is obviously more dense than a crumpled piece of paper. Right? We will know from our own experience. So we define our first term, density, mass per unit volume. Mathematically, I can write it in this form, density equals mass over volume. Or in symbol form, you cannot write lah. You have to define the term lah in the exam. Mass over volume. Mass is in kilogram. Volume is meter cube. Right? Or you can use a triangle to help you. Whatever you calculate. Okay, the unit is kilogram meter minus 3. 1 gram is 1000 kilogram meter minus 3. You should be able to show that. We use the Greek alphabet rho to represent density. It's a scalar quantity. Water is 1000 kilogram meter minus 3. Air is 1.3. So it's roughly about 1000 times bigger lah, the density of water compared to the air. So these two you need to remember lah, memorize it lah. They can ask you lah in the exam. Right? In general, density of liquid is approximately the same as density of solid. This evidence to show that the separation of particle in solid and liquid are almost the same. Liquid has a slightly lower density compared to solid. The only exception is ice, different structure. So water is heavier than ice. Usually it's a solid that's heavier. Density of gas is 1000 times, right? We have pointed out about 1000 times smaller than density of liquid. You can use this triangle to help you. You want to find force is pressure times area. You want to find pressure, force over area, you just cover the pressure up. What is the purpose of the airbag? Any idea?
Reduce impulsive force on the head.
Say again.
Reduce impulsive force on the head.
Basically, we go to our physics. Right? Newton's second law. We want to increase the time of impact.
Oh,
By increasing the time of impact, we reduce the force. Right? Why is the airbag as a large surface area? Any idea?
to spread out the impact.
To spread out. The force is spread out over a larger area, so the force per unit area is smaller. Right? So the force on our chest will be smaller also. Same. Right? Until 1860, skiing was primarily used for practical transport purposes in snow-rich area. Why can't you just walk on the snow? Same thing. Area is small, weight is large, so the pressure is large. So the person will sink in the snow, cannot walk in the snow. But when you increase the pressure by using the ski, you increase the surface area in contact, then you reduce the force per unit area. Okay, we define pressure. Pressure is defined as a force acting normally per unit surface area. I can write in formula form, normal force over surface area. That's the area or the surface, and that's the normal force over area. Normal means the force must be perpendicular to the area. So normal force is usually the weight of the object. State the unit of pressure. Right, go to the formula. Force is Newton. Area is meter square. Or we can write in Newton is kilogram. Right? Mass times acceleration. Meter as minus 2. Then cancel one mass there. So these are all the different units of pressure. If you can remember. If not, derive it. Right? It will come out in objective question. This one. That's the base unit. The unit of pressure in base unit. It's a scalar quantity. Unit of pressure. Pressure can be in millimeter mercury or meter head of water. Normal atmospheric pressure is 76 cm mercury. That means if you use mercury in a glass tube, that is 76 cm. Or we call it 1 atmosphere. Or if you use water, then it's 10 meter of water, which is very high. It's 1.0. 1 times 10 to the power 5 Pascal. You need to remember the value roughly 1 times 10 to the power 5 Pascal. Memorize.
Huh?
Memorize. Roughly lah, 1 times 10 to the power 5 Pascal. That's atmospheric pressure.
So 76
If you use
centimeters
mercury,
is
it's 76
one.
cm, no? The height. If you use water, it's 10 meter, no? Can? If you use SI unit, it's 1 times 10 to the power 5 Pascal.
Okay.
Okay. Pressure in fluid. You got atmospheric pressure. That is the surface of the water or liquid. Pressure at the point in a liquid depends on H rho G plus atmospheric pressure. So if that is depth below, H is the depth below the surface, right? Depth below the surface, density of the liquid, acceleration due to gravity, and atmospheric pressure. Sometimes people will use AT or H. So the pressure at a point below the surface of liquid is given by this equation. Okay, let's derive P equals to H rho G. Right, remember our definition for density. When derivation for pressure, we have to use the definition, how we define it first. So we consider a cylinder of liquid of height h, right? That's our definition for pressure. Pressure at the base, right? At the bottom of the beaker, due to the liquid alone. Volume of the liquid is cross-sectional area, right? At the base area times the height. Mass of liquid is volume times density from here. Mass is volume times density, and replace the volume with AH. Weight is just mg, right? It's m. Right? M is AH times rho, AH times rho, and times the G. Pressure, we use the definition, how we define it. Pressure is force over area, cross-sectional area. So force, which is the weight, is AH rho G divided by A. A and A cancel off, we got H rho G.
Oh,
Right? Or in the syllabus is given as delta P equals to delta H rho G. Can, you need to know how to derive.
that's
Okay, sketch a graph to show how the pressure varies with depth from the surface. Right? If we take our surface as 0 and H as a depth, right? H as a depth, that's the depth of the water, capital H. That's the bottom is the seabed. So we write a formula. Pressure at a depth H is H rho G times your plus your atmospheric pressure. Then we compare to the equation of a straight line. H compared to X, AT compared to C. So M equals to gradient equals to M. Okay, so we get a straight line starting with the atmospheric pressure. Okay, so
good.
if we want to consider the bottom as our origin, then there is a line. No? Atmospheric pressure doesn't change with short distance, short height. Right? That's why it's horizontal, this part. Okay. Anything that's not clear? It's just opposite to this one, that's all. opposite to this one. Okay or not? Anything not clear?
Yeah, clear.
Oh, this is your manometer tube. Used to find density. We will work this one out in a while lah. But usually we use this formula lah. H1 rho 1 G equals H2 rho 2 G. We take a horizontal line through here lah. Then the pressure at this point there and the pressure at this point there is the same lah. We'll work it out. Right? Idea is that we take a horizontal line. That's your seesaw if you like, and then there's your fulcrum lah. And then this is your liquid and atmosphere, lah. Or we can think of it as like a weighing on a scale balance. Determine density of liquid. Right? Density of water is given. Height is given. H1. Density of oil is rho 2. H2. So we want to find density of oil. Pressure at the same surface of mercury. Right? We take that line there. Same pressure on the mercury level. So we use H rho G is the same for both sides. Right? On the left-hand side of the limb is H1 rho 1 G plus atmospheric pressure. That's the air column there. And on the right-hand side is the right-hand limb. Same H2 rho 2 G times the atmospheric pressure, the air column there. Then we put in our value. H1 is 53 cm. Change it to meter. Density of water is 1 × 10⁻³ times your G. Atmospheric pressure cancel off. We don't bother about that. Equals to 71 cm. Change it to meter. Density is what we want to find. We call it rho and G. To simplify it, we get our answer. Can? In 10 minutes, finishing off.
Can.
Oh, can, huh?
Yeah.
Okay, let's carry on then. Page 116. A Greek mathematician and inventor named Archimedes noticed that when he stepped into his bathtub, the water level rose. He reasoned that the weight of water he displaced was equal to the buoyant force in water. This is Archimedes' principle and applied to all fluid, liquid or gas. Okay, let's look at that. Upthrust, Americans tend to call it buoyant force. When we wooden block in water, it will float. Call that upthrust. I use U lah. Your syllabus use it as F lah. Doesn't matter lah. And the weight is W. Upthrust is the upward force of the liquid on the object floating. Right? It's the upward force of the liquid pushing up on the wooden block. Okay, origin of upthrust. Why do we have upthrust? Well, let's put the object in the liquid, or we call it immerse. The top surface is H1 below the surface. The bottom surface is H2 below the surface. The height of the object is H. Density of the liquid is rho. Object immersed in liquid. This is inside the liquid lah. Pressure increases with that. That's the first thing. Why we have upthrust, pressure increases with that. When an object is placed in a liquid, immersed, pressure P2 is the bottom there, and pressure P1 below the object is greater than the pressure P1 above the object. Right? Pressure below here is greater than the pressure above the object. If there's a difference in pressure, Right? P1 is H1 rho G, P2 is P2 rho G. So P2 is greater than P1. The upthrust is due to the difference in pressure between the upper and lower surface of the object. So there's our upthrust. Right? Difference in pressure, P2 minus P1 times area. Right? We are using the definition of pressure. Volume of the cylinder is area of the surface times L, or in this case it's H. Right? We are using the definition. Pressure is force over area in this case. Okay, let's derive it. Object immersed in liquid, excess pressure. Right? Factorize it. H2 minus H1 rho G. Right? Basically, it's P2 minus P1. P2 is H2 rho G. P1 is H1 rho G. So take out the rho G. You got H2 minus H1. H2 minus H1 is the height of the cylinder. Okay. Upthrust equals to excess pressure times cross-sectional area. That's what we just say. Right? Using our definition, excess pressure times cross-sectional area. Excess pressure is this one. Cross-sectional area is A. Then remember that our volume is AH, volume of the cylinder. So replacing that, we get V rho G. So V rho G is called the weight of fluid displaced. Okay, so far? Anything, anything not clear?
So what is the official formula for upthrust?
Okay. F equals to volume times density times G.
Oh, okay, yeah.
Okay,
Yeah.
right, that's the formula. If you can just remember lah, where G lah, rho is the E lah. That will help you lah.
Okay.
Remember, it's given in the formula sheet. So remember, it's easier lah, faster. V is the volume of object in air, density of air. In air, density is about 1,000 times less than that of the object. Upthrust in air is usually neglected when we weigh an object in air. So weight of object in air is basically we take it as a weight in air, because upthrust in air is negligible. Too small, density is too small.
Okay.
Volume of fluid displaced for a floating object, the volume of liquid displaced equals to volume of solid below the surface, water. Okay, the floating object will sink until the volume of fluid displaced equals to volume of, until the upthrust equals to weight of the object lah. Right? There's the volume of fluid displaced. Volume of solid is V. For floating of body, if I push it downwards, the volume of liquid displaced increases, upthrust increases. When all the solid is in the liquid, the upthrust is constant. Right? If it's floating, the weight equals to upthrust. If I push it further down, it will still increase until the body is completely inside a liquid. Then you keep on pushing it down, the upthrust is still the same. But when you let go, it will move outwards because it always want to float. Upthrust is constant already when you move it inside the liquid. Object falling with constant
So
speed.
upthrust is always constant.
If the solid is in the liquid, you can move it inside
Or
the
fully immersed.
fully immersed.
If still floating, then it's not constant.
If it's floating, the weight equals upthrust. But if you push it down, upthrust increases.
Oh, okay.
What are the forces acting? Right, we will be cut off, but we will spend about 10 minutes, 10 to 20 minutes. I give you about 10 minutes break.
Okay.
You can try the question if we got cut off. We have more or less finished already. Weight of object, W. Friction or air resist of drag in the liquid is F. It's always opposed motion. Then you got upthrust, U. So the forces, if it's moving with constant velocity, then it's in equilibrium. W equals to U plus F. So we know W is greater than U, greater than F.
Oh, can I ask?
Yep.
Why is there friction inside the water?
Basically, it's the resistance of the liquid against the moving object. That's why we call friction. Or sometimes we call it drag. Drag. It's always opposed motion.
What scenario? I mean, I cannot imagine it.
Same like solid friction. When you put an object over a rough surface, there's friction. So this is the same thing. When the object is moving in the liquid, there's a friction that opposes the motion.
Also, if the object is rough, it's harder to
Doesn't
sink.
matter rough or not. The liquid will oppose the motion. Only
Okay.
when it's solid moving against solid, then it must be rough.
Or liquid doesn't matter, smooth or rough.
If it's liquid, doesn't matter. As long as the object is moving, there will be a friction opposing